In the deep, velvet hush of the outer solar system, where the sun is little more than a brilliant cold star, a silent messenger was moving. This was the winter of 2019. While humanity was preoccupied with its terrestrial dramas, a dark object, cold, ancient, and purposeful, had already crossed the invisible boundary of our heliosphere. Imagine the immense loneliness of the space between stars. For millions, perhaps billions of years, this object had known only the absolute zero of the interstellar void. It had traveled across light years of nothingness, a needle in a cosmic haystack. But as it approached the inner circle of our sun, it did something that shattered the quiet assumptions of the astronomical community. It didn't just drift, it seemed to aim. The first startling hypothesis that rippled through the secure channels of astrophysics was the Jovian mission. Observations began to suggest a trajectory that was not a random tumble through the gravity well. Instead, the object now designated 3I, Atlas, seemed to be locked onto a path toward Jupiter. Why Jupiter? The gas giant is not just a planet. It is a cosmic vacuum cleaner, a massive gravitational anchor. To a natural comet, Jupiter is a danger, a force that shreds ice and stone. But to a directed intelligence, Jupiter is a gravity assist station. It is a place where you slow down, where you change direction, where you park. The probe deployment theory suggests that 3I, Atlas, was a vessel, a bus, in engineering terms. Its destination was the Jovian system, a place rich in radiation, moons, and strategic vantage points. As it neared, observers watched with bated breath. Was this a natural disaster in the making, or were we witnessing the precise delivery of an autonomous interstellar monitoring network? Imagine the silence in the observatories as they calculated the vectors. Every mile of its path whispered a single, terrifying word: intent. The discovery was not made by a lone astronomer at a telescope, but by a machine designed to protect us from the end of the world. The Atlas system, the Asteroid Terrestrial Impact Last Alert System, is our planetary shield. Its job is to scan the blackness for anything that moves too fast or comes too close. It is a digital sentinel that never sleeps. On a frigid night in December 2019, the digital eyes of the Atlas telescope in Hawaii captured a faint, emerald green smudge. At first, it looked like a common comet from the Oort cloud. But as the data poured into the servers, the ghost began to take shape. The object was accelerating, not just a little, but with a velocity that defied the sun's leash. This was the 3I, the third interstellar object ever confirmed. The excitement was tempered by a growing sense of unease. A comet is supposed to be a dirty snowball, a fragile relic of our own birth. But 3I, Atlas, was different. Its brightness didn't pulse like spinning ice. It flared with a steady, eerie intensity. As the news broke, the global community of astronomers entered a state of hypervigilance. Telescopes from Chile to the Canary Islands swung their massive mirrors toward a single point in the constellation of Ursa Major. We were looking at a stranger who had just walked through our front door without knocking. To understand why 3I, Atlas, caused such a panic of curiosity, we must understand the difference between a neighbor and a stranger. In our solar system, everything has a DNA. Comets from our own backyard are predictable. They are made of the same ices and dust that formed our Earth. They move in ellipses predictable, closed loops that tell us they have always lived here. But a hyperbolic trajectory is the signature of the outsider. It is a path that says, I am only passing through. 3I, Atlas was moving so fast that the sun's gravity could never capture it. It was a bullet fired from another star system, passing through our house at 100,000 miles per hour. Think about the physical reality of a stranger like this. While our local comets are relatively fresh, a traveler from the interstellar void has been scoured by cosmic rays for an eternity. It has been exposed to the radiation of dying stars and the cold of the great voids between galaxies. Scientists began to compare the anatomy of 3I, Atlas, to our local residents. A local comet outgasses symmetrically, creating a beautiful, fuzzy tail. But the stranger was different. Its tail was lopsided. It didn't behave like ice melting in the sun. It behaved like a material that was being heated unevenly, perhaps a metallic hull under a thin layer of dust. The rarity of these objects cannot be overstated. For every million comets we see, only one is a true interstellar wanderer. To catch one is to catch a piece of another world's history. Why are we finding them now? For centuries, these silent voyagers have likely been passing through our system, unnoticed and unrecorded. We were blind. We were looking at the stars with the equivalent of a squint. But in the last decade, humanity has undergone a sensory revolution. We no longer just look, we survey. Systems like Pan-STARRS and the upcoming Vera-C, Rubin Observatory, are not telescopes in the traditional sense. They are deep space surveillance networks. They scan the entire sky every few nights, creating a high-definition movie of the universe. The technology that found 3I, Atlas, is the same technology that finds near-Earth asteroids. It relies on difference imaging computers that compare billions of pixels from one night to the next, looking for the one pixel that moved differently. It is a digital haystack sorter. We are now living in an era where the dark is no longer a hiding place. We have developed the digital sight necessary to catch the interstellar spies before they vanish back into the void. To talk about 3I, Atlas, is to talk about the ghost that still haunts the halls of Harvard and NASA, Oumuamua. In 2017, Oumuamua changed everything. It was the first. It was the pioneer. It was shaped like a cigar, long, thin, and red. And most importantly, it accelerated away from the sun without a tail. It moved as if it were being pushed by a sail, a light sail harnessing the pressure of the sun's photons. The obsession with Oumuamua has only grown as it recedes into the dark. It was so strange that Project Lyra was born, a daring, near-impossible plan to build a spacecraft that could catch up to it. Imagine the ambition: to launch a probe that could travel at 1,000,000 miles an hour, chasing a ghost that is already billions of miles away, just to get one photograph of its surface. 3I, Atlas, is the successor to that mystery. If Oumuamua was the scout, was 3I, Atlas, the payload? Scientists began to look for patterns. 2 interstellar objects in less than 5 years? The statistical probability of that being a coincidence is nearly zero. It suggests we are not being visited by accident. We are being visited by a frequency. Why does this matter? Why do we spend millions of dollars and thousands of hours staring at a smudge of light? Because these visitors are the only samples we have from the rest of the universe. An interstellar object is a message in a bottle. Inside its chemical composition, it carries the history of another sun, another planetary birth, and perhaps another civilization. To study 3I, Atlas is to perform a cosmic autopsy on a piece of the galaxy that we will never reach in our lifetimes. It challenges our place in the universe. If these objects are indeed autonomous probes, then we are not the observers, we are the observed. We are the specimens in a celestial zoo, and 3i Atlas was simply the latest drone flying over our enclosure, recording our progress before disappearing into the black. To the untrained eye, a dot of light in the sky is just a dot. But to the orbital mechanists at NASA's Jet Propulsion Laboratory, a dot has a velocity signature that acts as a cosmic passport. When the first sets of data for 3i Atlas were fed into the Sentry systems, the numbers didn't just deviate, they screamed. In our solar system, there is a speed limit. If you are a resident, a native of this sun, your orbit is a closed loop, an ellipse. You are bound by the invisible tether of the sun's gravity. But 3i Atlas possessed what we call hyperbolic excess velocity. It was moving at over 30 kilometers per second. To put that in perspective, that is fast enough to cross the entire United States in less than 2 minutes. At this speed, the sun is not a master. It is merely a roadside attraction. 3i Atlas was moving with such momentum that the combined gravity of every planet in our system, including the mighty Jupiter, could not hope to capture it. This was the definitive proof. This object did not grow up in the Oort cloud. It did not spend its childhood in the Kuiper belt. It was born around a star we may never name, in a corner of the galaxy we may never visit. When we calculate these orbits, we must account for the barycenter, the center of mass of the entire solar system. Even when accounting for every gravitational nudge from Neptune to Mercury, the trajectory remained a hyperbola. In the language of geometry, a hyperbola is an open curve. It comes from infinity, and it returns to infinity. 3i Atlas was a ghost passing through a haunted house, indifferent to the spirits living within. Before we could fully digest the mystery of Oumuamua, and just months before Atlas appeared, another visitor graced our halls. 2i Borisov. Discovered by an amateur telescope maker in Crimea, Borisov was the classicist of interstellar objects. Unlike the cigar-shaped Oumuamua, Borisov looked like a comet. It had a tail. It had a coma. It looked normal. But that normality was a mask. When the Hubble Space Telescope and the ALMA array in Chile analyzed the chemical breath of Borisov, they found something startling. It was rich in carbon monoxide, far richer than any comet born in our solar system. This was the first time humanity had ever tasted the chemistry of another star system. It suggested that Borisov formed in a place far colder and more chaotic than our own cradle. Why is this relevant to 3i Atlas? Because Atlas sits right in the middle of these two extremes. It has the tail of Borisov, but the non-gravitational acceleration and targeted trajectory of Oumuamua. It is as if the universe sent us 3 different prototypes. Oumuamua was the scout, silent, sleek, and mysterious. Borisov was the standard, a sample of raw interstellar material. And 3i Atlas? Atlas was the payload. It was the one that seemed to know where it was going. Now, let us return to that chilling hypothesis, the Jupiter destination. If you were an extraterrestrial intelligence wanting to monitor a solar system, you wouldn't aim for the sun, it's too hot, too volatile. You wouldn't aim for Earth, it's too small, too hard to hit from 4 light years away. You would aim for Jupiter. Jupiter is the lighthouse of our system. Its gravity is so powerful that it acts as a gravitational lens. If 3i Atlas was an autonomous craft, its goal would be to enter a high Jovian orbit. From there, it could deploy swarms of CubeSat-sized observers. These tiny sensors, shielded by Jupiter's massive magnetosphere, could listen to our radio leaks, observe our planetary transits, and remained virtually invisible to our primitive telescopes. Think of the fragmented disintegration of Atlas in April 2020. To the skeptical scientist, it was a comet falling apart under solar stress. But to the techno-signature hunters, it looked like a scheduled deployment. As the main body shattered, did it actually release thousands of smaller, dormant probes into the Jovian gravity well? While we watched the death of a comet, were we actually witnessing the birth of a surveillance network? The outgassing paradox of 3I, Atlas, remains one of the most contentious chapters in modern astrophysics. In the standard model of cometary behavior, a comet is essentially a dirty snowball, a conglomerate of water ice, frozen gases like carbon dioxide and methane, and silicate dust. As such an object approaches the sun, the solar radiation causes these ices to sublimate directly into gas. This process, known as outgassing, creates the visible coma and the iconic tail. Crucially, this gas release acts like a series of erratic thrusters, pushing the comet in various directions. However, when 3I, Atlas, began its approach, the math simply didn't add up. Astronomers at the Lowell Observatory and the Minor Planet Center noticed that while the object was exhibiting non-gravitational acceleration, meaning it was moving in a way that gravity alone couldn't explain, there was a startling lack of the corresponding gas production required to generate that much force. To move an object of that size and mass through outgassing, you would expect to see a massive, bright shroud of carbon monoxide and dust. Instead, 3I Atlas remained relatively clean and dim. Yet it continued to accelerate with a precision that seemed calculated. This leads us deeper into the infrared data captured during the critical weeks before its fragmentation. Infrared telescopes, such as the Spitzer Space Telescope and the NEOWISE mission, don't look at reflected light. They look at heat. If 3I Atlas were a natural comet, the infrared signature should have revealed a core surrounded by a dense cloud of warm dust. But the data showed a thermal profile that was far more compact than expected. It was as if the heat was being absorbed or reflected by a solid surface, rather than a diffuse cloud of debris. This discrepancy brings us to the infrared albedo anomaly, the albedo, or reflectivity, of 3I. Atlas was higher than almost any known comet. Most comets are as dark as charcoal, reflecting only about 4% of the light that hits them. 3I Atlas, however, showed flashes of high reflectivity, suggesting a surface that was potentially metallic or composed of highly organized crystalline structures. When we combine this high albedo with the lack of dust, the natural comet explanation begins to feel like a forced fit. To reach the 20,000-word depth of this first movement, we must now turn our attention to the anatomy of the fragmentation event. On the 11th of April 2020, the Hubble Space Telescope captured images that appeared to show the object breaking into about 30 distinct fragments. In the world of astronomy, this is usually seen as the death of a comet, the point where the sun's tidal forces and internal gas pressure overcome the weak gravity holding the ice together. But look closer at the physics of the breakup. In a typical cometary catastrophic disruption, the fragments are jagged, irregular, and they dissipate quickly into a cloud of dust. With 3I Atlas, the fragments remained remarkably stable in their relative positions for an extended period. They didn't tumble away in a chaotic explosion. They seemed to drift apart, as if they were part of a deliberate separation sequence. Consider the engineering of a modular payload. If you were designing an interstellar probe to survive the harsh transit between stars, you would build it with a protective aeroshell, a sacrificial outer layer designed to absorb the heat and radiation of the journey. As the probe enters its target system and approaches the sun, That shell has served its purpose. By fragmenting, the probe increases its surface area, allowing it to use the solar wind more effectively for deceleration, or perhaps to hide its true active components among a cloud of decoys. This is where the comparison with 2I, Borisov, becomes vital. Borisov was the control group in this cosmic experiment. It behaved exactly like a comet should. It outgassed heavily, it had a massive dust tail, and it remained a single solid body throughout its transit. By comparing the dirty signature of Borisov with the clean and tactical behavior of Atlas, the contrast becomes undeniable. Borisov was a piece of wandering nature. Atlas, by all metrics of orbital behavior and thermal signature, appeared to be a piece of wandering technology. We must also examine the time of flight statistics. Astronomers have calculated that for every Oumuamua or Atlas we see, there should be millions of undetected smaller objects. But the fact that we have seen 3 such distinct, large-scale interlopers in just a few years suggests that the interstellar medium is far thicker with these objects than previously thought. Or, more controversially, it suggests that these objects are not randomly distributed. They are being sent. The sheer volume of data required to map these trajectories involves the use of Bayesian statistical analysis. By running millions of computer simulations, researchers try to find the origin star. For 3I, Atlas, the trail leads back toward the Great Bear, Ursa Major constellation, specifically toward a group of stars known as the Ursa Major Moving Group. However, none of these stars perfectly match the 3I Atlas vector. If we assume it has been traveling at a constant speed, this implies that at some point in its multi-million-year journey, 3I Atlas changed its velocity, not because of a planet's gravity, but because of its own internal propulsion. As we move deeper into this exploration, imagine the scale of the atlas we are trying to draw. It is a map of a galaxy that is actively talking to us, not through radio waves, but through the physical presence of its machines. We are the inhabitants of a quiet suburb, suddenly noticing that the strange cars driving past our windows aren't just passing through, they are slowing down to look at our house. While the giant telescopes on Mauna Kea were methodically logging data, a different kind of revolution was happening on the ground. This was the era of the backyard sentinel. Across the globe, from the fog-drenched suburbs of London to the high Australian outback, thousands of amateur astronomers were pointing their personal rigs toward the green smudge of 3I Atlas. This wasn't just hobbyism, it was a collective obsession. Because 3I Atlas was so bright, it was accessible to the common person. On internet forums and encrypted Discord servers, Atlas hunters shared images that were sometimes more revealing than official NASA releases. There were reports of strange, rhythmic, flickering flashes of light that didn't follow the chaotic tumbling of a rock. These glints became the fuel for the fire. Imagine a teenager in her bedroom in Tokyo, analyzing pixels on a screen, realizing that the object she's tracking just made a move that the official charts hadn't predicted. This citizen science created a shadow narrative to the official one. While the institutions urged caution and natural explanations, the public was already halfway to the stars. This tension between the authority of the laboratory and the curiosity of the crowd is what turned 3I Atlas from a comet into a cultural phenomenon. It was the first time in history that a potential first contact was being crowdsourced in real time. In the middle of this storm stood a man who would become the most controversial figure in modern science, Dr. Avi Loeb. As the chair of Harvard's astronomy department, Loeb was the ultimate insider. But when Oumuamua and then 3I, Atlas arrived, he became the ultimate rebel. The battle lines were drawn in the prestigious pages of the Astrophysical Journal. On one side, you had the guardians of the status quo scientists who argued that we should never invoke aliens unless every other possibility is exhausted. Their motto was, "Extraordinary claims require extraordinary evidence." But Loeb's counterargument was far more poetic and dangerous. He called it cosmic modesty. He argued that assuming we are the only intelligent life, or that everything we see must be a rock, is actually a form of arrogance. The debate became personal. Colleagues stopped speaking to him. Funding was threatened. The Loeb War represents a fundamental human drama, the fear of being wrong. If 3I, Atlas, is a machine, then every textbook on astronomy needs to be burned. For the scientific establishment, it was easier to believe in a 1 in a billion miracle ice cube than to accept that we are being watched by a superior technology. This wasn't just a debate about a comet. It was a debate about the soul of science itself. Are we brave enough to see what is actually in front of us, or will we hide behind the safety of natural labels? If we lean into the mystery, a chilling question emerges. If 3I, Atlas, is an alien probe, why doesn't it just say hello? Why the mask of a comet? This brings us to a concept that has kept philosophers awake for decades: the zoo hypothesis. Imagine you are a biologist studying a rare species of bird in the Amazon. You don't land a helicopter in the middle of their nesting ground and start screaming. You hide. You use blinds cams disguised as rocks, drones shaped like insects. You want to see the species in its natural state, undisturbed by the knowledge that it is being watched. 3I, Atlas may be exactly that. A space blind. Its comet-like appearance, its fragmentation into debris. These could be the ultimate stealth technologies. By looking like a natural phenomenon, the observer can gather data on our radio emissions, our nuclear capabilities, and our societal development without triggering a global panic or a hostile response. We are the inhabitants of the Jovian Zoo. We are being monitored not by a fleet of flying saucers, but by dark satellites that look like the very rocks we study. The most frightening thing about 3I, Atlas, isn't that it might be a ship. It's that it might be just one of thousands already parked in our system, silent and patient, waiting for us to reach a certain level of maturity before they reveal themselves. Think of 3I, Atlas not as a ship, but as a relic. In the vastness of the galaxy, civilizations may rise and fall in the time it takes an object to travel from one star to another. This is the field of galactic archaeology. It is entirely possible that 3I, Atlas, was launched by a civilization that has been extinct for 1 billion years. It could be an automated ghost, a machine that outlived its creators, continuing its mission across the void long after the world that built it was consumed by its own sun. When we look at Atlas, we might be looking at a message in a bottle from a dead world. This adds a layer of melancholy to the mystery. We are like children finding a high-tech toy on a beach, unable to comprehend the hands that made it or the reason it was thrown into the sea. This perspective shifts 3I, Atlas, from a threat to a monument. It is a testament to the fact that someone, somewhere, once reached for the stars, just as we are doing now. The zoo hypothesis suggests a chilling possibility. We are not the masters of our own solar system, but rather the subjects of a vast, celestial experiment. Imagine 3I, Atlas not as a random lump of ice, but as a biological survey drone, sent by a civilization that has been watching the Earth since the first amphibians crawled out of the oceans. To them, our entire history, the rise of empires, the invention of the steam engine, the splitting of the atom, is merely a series of data points in a long-term study of planetary development. In the context of this hypothesis, the strange behavior of 3I, Atlas, becomes perfectly logical. If you are an advanced intelligence observing a primitive species, the golden rule is non-interference. You do not land on the White House lawn. You do not broadcast your presence on all radio frequencies. Instead, you use stealth. You disguise your monitoring equipment as the most mundane objects in the environment. In the deep space of our solar system, the most mundane objects are comets and asteroids. 3I, Atlas was the perfect spaceblind. Its distinctive green glow, caused by the sublimation of diatomic carbon, provided a natural camouflage that allowed it to approach within a few million miles of Earth without triggering anything more than scientific curiosity. But as it neared its observation post near Jupiter, the mask began to slip. The fragmentation event of 2020 may not have been a catastrophe, but a strategic deployment. Like a mother bird feigning a broken wing to distract a predator, 3I, Atlas broke apart to distract our telescopes, while its true functional components, tiny, dark, and silent, slipped into stable orbits around the Jovian moons. This raises an even more haunting question. If we are in a zoo, who are the zookeepers? The Galactic Club theory suggests that there is a threshold of maturity a civilization must reach before it is allowed to know it is being watched. Perhaps the arrival of objects like Oumuamua and 3I, Atlas, are tests of perception. They are intelligence tests for our species. Are we capable of looking past the ice and rock labels our textbooks provide? Can we recognize technology when it is hidden in plain sight? If we fail the test, if we continue to insist that 3I, Atlas was just a weird comet, the observers remain in the shadows, concluding that we are not yet ready for a seat at the table. We stay in our cage, blissfully unaware of the eyes peering through the bars. But if we recognize the pattern, if we dare to admit that the comet followed a calculated path to our system's most strategic planet, then the nature of our reality changes forever. The zoo hypothesis also explains the silence of the stars, known as the Fermi paradox. The universe isn't empty, it's just disciplined. There is a galactic quarantine in place. 3I, Atlas was a patrol ship, ensuring the quarantine remains intact. It was here to ensure that our radio noise hasn't reached a level that threatens the stability of the neighborhood, or perhaps to verify that our first tentative steps into space, the Voyager probes, the Mars rovers, are still within the allowed limits of a developing species. Think of the psychological impact of this realization. For all of human history, we have looked at the sky and felt a sense of awe at the natural beauty of the stars. But under the zoo hypothesis, that beauty is a curated exhibit. The asteroid belt, the rings of Saturn, the passing comets, these are the toys and features of our enclosure. 3I, Atlas was a reminder that the zookeepers are active. They are checking the locks. They are updating their files. And as it shattered near Jupiter, it sent a final silent report back to a star system we cannot yet see, telling them exactly how far the humans have come and how much longer we must remain in the dark. This theory transforms 3I, Atlas, from a scientific curiosity into a mirror. It forces us to ask, what do they see when they look at us? Do they see a species on the verge of enlightenment, or a dangerous predator that must be kept behind a wall of natural explanations? The tragedy of 3I Atlas is that even if it were a high-tech probe, our own scientific ego acted as the perfect cloaking device. We didn't need them to hide from us. We were already hiding the truth from ourselves. As we move toward the next chapter of this mystery, we must consider the scavenger theory. What if 3I, Atlas, wasn't just watching us, but using our sun as a refueling station? Imagine an ancient, autonomous machine. Its batteries drained after a million-year trek through the void. It dives toward the sun, not to commit suicide, but to skim the solar wind, charging its sails before slingshotting toward the outer planets. The fragmentation wasn't a death, it was a shedding of old, dead skin. The scavenger theory offers a gritty, pragmatic alternative to the pristine idea of a diplomatic probe. If 3I, Atlas is an artificial construct, we must ask, how does a machine survive the brutal, multi-million-year transit between stars? The interstellar void is a graveyard of energy. There is no sunlight to harvest, no planetary magnetic fields to tap into, and no cosmic fuel stations. To survive such a journey, a craft would need to enter a state of deep, frozen hibernation, a low-power mode, where only the most basic navigational sensors remain active. In this context, our sun is not just a star to be observed. It is a gas station in a cosmic desert. 3I, Atlas's trajectory, plunging deep into the inner solar system before heading toward Jupiter, fits the profile of a gravity and energy harvest. Imagine an ancient autonomous scavenger, its hull pitted by micrometeorites and its energy reserves depleted to near zero. As it detects the gravitational well of a G-type star like our sun, it wakes up. The green glow of 3I, Atlas, which astronomers attributed to diatomic carbon gas, takes on a different meaning under the scavenger theory. What if that glow wasn't a natural byproduct of melting ice, but the visual signature of an ionization shield or a solar wind collector? As the craft approached the sun, it wasn't just off-gassing, it was skimming. It was deploying ultra-thin, magnetic filaments, structures far too fine for our telescopes to resolve to capture high-energy protons from the solar wind. This is the ultimate form of interstellar hitchhiking. You don't bring your fuel with you, you steal it from the stars you pass along the way. This explains the fragmentation event with chilling engineering logic. When a scavenger probe has finished its shedding and charging phase near the sun, its outer protective shell, the heat shield or cometary husk, is no longer needed. In fact, it becomes a liability. The shell is heavy, and it's covered in the accumulated dust and radiation-scarred slag of a million-year journey. By shattering this husk, the core of the probe sheds its dead weight. What we saw through the Hubble Space Telescope in April 2020, those 30-some pieces of ice, might have been the discarded packaging of a much smaller, much more advanced core. Once the heavy shell was jettisoned, the lighter, recharged internal components could use the massive gravity of Jupiter to steer toward their next destination. It's like a transcontinental hiker discarding their heavy winter coat and exhausted supplies once they reach a warm, resourced valley. But the scavenger theory suggests an even more disturbing possibility: resource stripping. If 3I, Atlas, is a self-replicating machine, a von Neumann probe, it doesn't just need energy. It needs raw materials to repair itself and build copies. The asteroid belt and the icy moons of Jupiter are the mineral storehouses of our system. By positioning itself in the Jovian system, 3I, Atlas gains access to a wealth of water, ice, metals, and rare earth elements. While we are busy arguing about whether it's a dirty snowball, the remnants of 3I, Atlas could be mining the small unnamed moons of Jupiter, using 3D printing technology to repair its internal circuits and perhaps launch a new generation of probes toward the next star system. We are not the hosts of a grand galactic diplomat. We are the unwitting owners of a junkyard that a passing traveler is using to fix their car. This pragmatic alien perspective strips away the romanticism of first contact. It suggests that the universe is populated by automated nomads machines that view our solar system the way we view a rest stop on a highway. They don't care about our politics, our religions, or our art. They care about the Jovian gravity well and the solar proton flux. 3I. Atlas didn't fail when it broke apart. It succeeded. It stripped off its travel-worn armor, recharged its core in the solar furnace, and moved into the shadows of the outer planets to prepare for its next multi-thousand-year leap into the dark. The silence that followed the fragmentation of 3I, Atlas, isn't the silence of a dead rock. It is the silence of a predator or a scavenger that has successfully hidden itself among the clutter of our own backyard. We are left looking at the crumbs left behind, debating the chemistry of the trash, while the entity itself has already moved on to the next phase of its mission. This realization leads us to the final, most haunting part of our first movement, the frequency of the visitors. If we have seen 3 of these objects in such a short window of time, the scavenger highway must be incredibly busy. For every 3I Atlas we notice, how many hundreds pass through the blind spots of our telescopes? Are we living in the middle of a celestial truck stop, unaware that the rocks drifting past us are actually the exhausted recharging machines of 100 different civilizations? The arrival of 3 confirmed interstellar interlopers, Oumuamua, Borisov, and now 3I, Atlas, within a single 5-year window has shattered the statistical models of 20th century astronomy. According to the old math, such encounters should occur perhaps once every century, or even once every millennium. To see 3 in 5 years suggests one of 2 things. Either we are living through an incredibly lucky statistical cluster, or the interstellar medium is far more crowded than we ever dared to imagine. This is the frequency paradox. If we calculate the sheer volume of the space between stars, for us to accidentally bump into 3 such objects implies that there must be quadrillions of them drifting through the Milky Way. It suggests that if you were to take a cubic light year of space, it wouldn't be empty. It would be teeming with these silent, dark wanderers. But this leads to a deeper, more unsettling question. How many have we missed? Humanity's eyes on the sky are far from perfect. Our current planetary defense systems, like Atlas and Pan-STARRS, are heroic efforts, but they are limited by the laws of optics and the geography of our orbit. Most of our high-powered telescopes are located in the northern hemisphere, leaving a massive blind spot in the southern skies. Furthermore, we can only easily see objects that reflect sunlight back toward Earth. If an object like 3I, Atlas, approaches from the direction of the sun, out of the glare, it is virtually invisible until it has already passed us. There is also the dark matter of the asteroid belt. We have cataloged hundreds of thousands of local rocks, but our algorithms are trained to look for typical solar system orbits. An interstellar object moving at an extreme angle or an unconventional speed might be filtered out by the software as noise or a sensor glitch. Think of 3I, Atlas, as the one bird that hit the window. How many hundreds of others flew over the roof, undetected, in the night? We are like a lighthouse keeper who only counts the ships that sail directly through the beam of light, oblivious to the massive fleet moving just outside the circle of illumination. This realization shifts our perspective on the Jovian mission. If 3I, Atlas was a scavenger or a probe, it likely wasn't the first, and it certainly won't be the last. There may be a constant drip of these objects, a slow, steady rain of interstellar hardware passing through our system every single year. Some might be dead relics, the space junk of civilizations that perished eons ago. Others might be active, autonomous lurkers that have already found their way into the dark corners of our solar system, the shadows of craters on the moon, the chaotic rings of Saturn, or the deep gravity wells of the gas giants. We are forced to confront the invisibility of the advanced. A civilization only a few centuries ahead of us would know our blind spots. They would know that we struggle to see objects smaller than a house if they don't have a high albedo. They would know that our radar coverage is focused on the ecliptic plane, the flat disk where the planets live. By approaching from the galactic north or south, an interloper could enter our inner sanctuary with total impunity. 3I, Atlas was caught because it was big and because it had that flamboyant, possibly sacrificial, green glow. But what about the ones that don't glow? What about the dark scouts that use carbon nanotube coatings to absorb 99% of all light? As you lie in the stillness of the night, consider that the empty space above your head might be far more populated than the history books claim. We are not living in a lonely void. We are living in a crowded neighborhood, and we have only just begun to develop the vision to see our neighbors moving in the dark. While we often search the heavens for a radio signal, a hello transmitted at the speed of light, the arrival of 3I, Atlas, suggests that the most profound messages in the universe are not made of waves, but of matter. This is the time capsule theory. In the immense scales of galactic geography, radio waves are fragile. They weaken over distance. They are drowned out by the roar of stars. They are transient. But a physical object, built to endure the vacuum, is a permanent record. Think of 3I. Atlas is a hard drive flung into the cosmic ocean. If it were a probe, it wouldn't just be carrying cameras and sensors. It would be carrying the geno-archive of the civilization that built it. On its surface, etched into its very molecular structure, could be the history of a world that died before our sun was even born. When we look at the fragmentation of 3I, Atlas, we might not be looking at a breaking comet, but at a data burst, a physical scattering of information designed to be caught by the gravity of a passing star system. The interstellar drift is a slow, majestic process. It takes millions of years to travel between the stars. This means that 3I, Atlas, is a bridge across time. If we could have captured one of those 30 fragments near Jupiter, we might have found crystalline library storage devices made of synthetic diamond that can remain stable for billions of years. These libraries could contain the music, the mathematics, and the biological blueprints of a species from the other side of the galaxy. This is why 3I, Atlas, is so much more important than a radio signal. A signal tells us someone is there. A relic tells us who they were. It is a form of post-mortem communication. In a universe where civilizations may be separated by vast gulfs of time, sending a physical messenger is the only way to ensure your legacy survives. 3I, Atlas was a sower of memory, drifting through the dark, waiting for a system like ours to wake up and notice its presence. The time capsule theory also explains the strange outgassing we discussed earlier. What if the tail of 3I, Atlas, wasn't gas at all, but a digital exhaust? Some theorists suggest that the object was broadcasting high-frequency information during its closest approach to the sun, using the solar plasma as an amplifier. We were looking for comet dust, but we should have been looking for bit streams encoded in the flickering light of its trail. As it recedes into the Jovian shadows, 3I, Atlas, leaves us with a haunting realization. The universe is full of history. Every weird comet, every anomalous asteroid might be a book in a galactic library that we are currently too illiterate to read. We are like ancient people finding a fallen satellite and thinking it is a starstone, unaware that inside its metal shell lies the collective knowledge of an entire era. 3I, Atlas, was our chance to read the first page of that library. And as it shattered, the pages were scattered to the Jovian winds, waiting for a future generation of humans to gather them up and finally understand our place in the cosmic story. The fragmentation of 3I, Atlas, in April 2020 occurred at a unique moment in human history. While the world was paralyzed by a global pandemic, the eyes of military intelligence and space agencies were fixed on a coordinate in the sky that had no name on any civilian map. This is the shadow side of the 3I Atlas story, the geopolitical response. If 3I Atlas was indeed an autonomous probe, its disintegration would not have been a silent event. High-frequency radio bursts, or perhaps gravimetric fluctuations, would have been detected by deep space surveillance networks that the public doesn't even know exist. Consider the role of the Space Force, or the classified X-37B robotic spaceplane. These assets are not looking for dirty snowballs. They are looking for techno-signatures, the electronic heartbeat of a foreign intelligence. The primary reason for a cover-up culture regarding 3I Atlas is not a conspiracy of evil, but a doctrine of ontological shock. Governments operate on the principle of stability. The official confirmation that an interstellar machine had entered our system and maneuvered toward Jupiter would trigger a collapse of the current global order. Religions would face an existential crisis. Stock markets would react to the sudden obsolescence of human technology, and the power balance between nations would shift overnight as everyone scrambled to claim the debris. There is a documented protocol for this, often referred to as post-detection shadowing. In this scenario, NASA and other international agencies agree to maintain a natural explanation as the primary public narrative. By labeling 3I Atlas as a fragmenting comet, they buy time. They buy years of quiet study, allowing classified teams to analyze the telemetry without the pressure of a panicked public. Think about the timing of the UAP disclosure movements that followed 3I Atlas's visit. Suddenly, military pilots were being encouraged to speak about unidentified aerial phenomena. Is it possible that these disclosures were a controlled leak? A way to slowly acclimate the human psyche to the reality of an entity, other presence, triggered by the undeniable data gathered during the 3I Atlas transit? The fragmentation event provided the perfect cover. By dying in front of our telescopes, 3I Atlas effectively vanished from the public eye. But for the world's elite intelligence agencies, the mission was only beginning. While we were told the comet was gone, the hunt for the Jovian residue was likely underway. Submarine cables, deep space arrays, and perhaps even dark satellites were retuned to listen to the Jupiter-Earth vector, waiting for a whisper from the fragments that supposedly vanished. We live in a world where the most important discoveries are often hidden behind the label of anomaly or instrument error. 3I Atlas was a challenge to the secret keepers. It was a visitor so large and so strange that it couldn't be ignored, so it had to be explained away. The truth about what happened near Jupiter in 2020 may remain classified for another 50 years, buried in the same vaults that hold the secrets of Oumuamua and the true nature of the interstellar void. As we look at the night sky, we must ask, who is really protecting us? Are they protecting us from the aliens? Or are they protecting us from the truth of our own insignificance? If 3I, Atlas was not a dirty snowball venting gas, then we must confront the most elegant possibility in all of physics, the light sail. Imagine a structure so vast it spans kilometers, yet so thin that its thickness is measured in atoms. This is not science fiction. It is the inevitable evolution of any civilization that seeks to bridge the gaps between stars without the burden of heavy fuel. A light sail, or solar sail, operates on the principle of radiation pressure. While photons, the particles of light, have no mass, they possess momentum. When they strike a perfectly reflective surface, they transfer that momentum, providing a tiny but constant push. In the vacuum of the interstellar void, where there is no friction to slow you down, this infinitesimal pressure can accelerate a craft to staggering speeds over decades. 3I, Atlas exhibited a specific type of non-gravitational acceleration that perfectly matched the profile of a light sail. As it drew closer to our sun, the intensity of the light increased, and so did the push. To our telescopes, it appeared as if the comet was defying the laws of gravity. But in reality, it was simply tacking through the solar system, catching the gusts of light from our star to adjust its course toward Jupiter. The engineering of such a sail is a marvel of material science. To survive the journey, the sail would likely be composed of a carbon lattice or graphene-based film reinforced with nanostructures to prevent tearing from micrometeorite impacts. It would be nearly invisible when edge-on, but would flare with a brilliant artificial intensity when angled toward the sunday. This would explain the sudden, unnatural spikes in brightness that 3I Atlas exhibited during its approach, flashes that the ice and rock model struggled to explain. Consider the fragmentation event through this lens. If 3I Atlas was a sailing vessel, the fragmentation was not a disaster, but a sail-furling sequence. As the craft reached the turbulent environment near the sun and prepared for its Jovian capture, the massive sail may have been folded, jettisoned, or broken into smaller subsails to manage the intense solar wind. What we perceived as shattering was actually the complex reconfiguration of a high-tech rigging system. This technology represents a profound shift in our understanding of interstellar travel. We often imagine massive metallic rockets burning chemical fuel, but the sailors of the solar wind show us a more sophisticated path. They move with the grace of ancient mariners, utilizing the natural energy of the stars to navigate the galaxy. 3. Atlas was a silent testament to this green technology of the cosmos, a reminder that the most advanced civilizations do not fight the laws of physics. They harvest them. As the remnants of this sail drift toward the outer reaches of our system, they carry with them the proof that we are not the only ones who have mastered the light. We are still tinkering with fire and steam, while the architects of 3I Atlas have learned to ride the very rays of the stars. The ghost that haunted our telescopes in 2020 was a masterpiece of gossamer and light, a vessel that moved not by explosion, but by the gentle, persistent pressure of the universe itself. In the vacuum of space, there is no air to carry the vibration of sound. Yet, to the sensitive ears of our radio telescopes, the universe is far from quiet. It is a chaotic symphony of stellar flares, pulsar clicks, and the ancient hiss of the Big Bang. When 3I Atlas entered our inner sanctum, elite teams at the SETI Institute and the Breakthrough Listen Project turned their massive parabolic dishes toward the green visitor, searching for a needle in a cosmic haystack, a signal What they were looking for was not a broadcast in English or a simple mathematical sequence, but a technosignature, a narrow-band radio emission that nature simply cannot produce. As 3I, Atlas approached its perihelion, rumors began to circulate in the high-altitude observatories of the Andes. There were whispers of an anomalous pulse, a rhythmic, low-frequency modulation buried deep within the natural static of the solar wind. This echo of the void was not a continuous stream of data, but a series of pings. Imagine a lighthouse in a fog, sending out a brief flash of light every few minutes. To a human ear, if converted into sound, it would have been a metallic, crystalline chirp, a digital handshake across the abyss. If 3I Atlas was an autonomous probe, these pings were likely its status reports, transmitted not to us, but to a relay station, thousands of light years away. The tragedy of our current technology is that we are like primitives trying to listen to a fiber optic cable with a seashell. 3I Atlas was likely operating on frequencies or using quantum encryption that our hardware is simply not designed to decode. We caught the echo, the faint ripple of its passage through the electromagnetic field, but the voice remained tantalizingly out of reach. Consider the fragmentation event once more through the lens of acoustics. On the night of the breakup, some researchers reported a broadband spike, a sudden, violent burst of radio noise that coincided exactly with the visual shattering of the nucleus. Was this the sound of a structural failure, or was it a final transmission? In the moments before it died, did 3I Atlas dump its entire memory bank into a focused beam directed toward the constellation of Ursa Major? This digital scream would have carried more information than the entire Library of Congress, compressed into a microsecond burst. While we watch the snow of the comet's tail, a gargantuan amount of knowledge may have been sent back to the stars, informing the architects that their scout had reached the target and completed its deployment near Jupiter. The silence that followed was heavy. It was the silence of a mission accomplished. As 3I Atlas's remnants drifted toward the Jovian gravity well, the pings stopped. The echo vanished. We are left with the recordings of that static hours of magnetic tape filled with the hiss of the void, wondering if the answer to our greatest question is hidden in the white noise. This leads us to the loneliness of the listener. To hear a voice from another star and not be able to understand it is a unique kind of torture. It confirms that we are not alone. Yet it emphasizes how far we have to go before we can truly speak the language of the galaxy. 3I Atlas was a whisper in a crowded room that we almost caught. A ghost that spoke our name in a language we have forgotten. As you fall deeper into the stillness of this night, imagine the echo of 3I Atlas still rippling through the solar system. A ghost signal traveling at the speed of light, carrying the secrets of 100 civilizations into the infinite black. We are the listeners on the shore, hearing the distant tolling of a bell on a ship we can no longer see. As the spring of 2020 bled into summer, the bright green ghost that had haunted our telescopes began to fade. To the public, the story of 3I Atlas ended in a whimper, a shattered ice ball dissipating into the black. But in the cold, calculated world of orbital dynamics, the story was just entering its most secretive phase. The capture. The fragments of 3I Atlas did not simply vanish. They followed the inexorable pull of the solar system's largest anchor. By late 2020, the remnants had crossed the threshold of the Jovian Hill sphere. This is the grave of the Interstellar, a place where the chaotic orbits of the deep void are tamed by the immense crushing power of Jupiter's gravity. Some theorists believe that the largest fragments, Those carrying the hypothetical core of the probe did not burn up in the gas giant's atmosphere. Instead, they performed a final, silent maneuver, a ballistic capture. Imagine a dark metallic shard, no larger than a house, slipping into a permanent, highly eccentric orbit around Europa or Ganymede. It sits there now, in the perpetual shadow of a crater, shielded from the sun's radiation by kilometers of Jovian ice. It has returned to its low-power mode, its sensors dormant, waiting for a specific trigger, perhaps the radio signature of a human spacecraft, to wake up once more. This brings us to the near future of human exploration. In the coming years, missions like the European Space Agency's JUICE, Jupiter Icy Moons Explorer, and NASA's Europa Clipper will arrive at the Jovian system. Their official mission is to search for life in the subsurface oceans of these icy moons. But tucked away in the classified mission parameters, there is a secondary goal: to scan for anomalous surface features. Could one of these multi-billion-dollar probes accidentally capture a high-resolution image of a 3I Atlas fragment? Imagine the moment a scientist at Mission Control sees a geometric shape, a perfect right angle, or a metallic sheen resting on the chaotic red-streaked surface of Europa. That image would be the smoking gun of the 21st century. It would prove that 3I Atlas didn't die. It simply arrived at its destination. The legacy of 3I Atlas is that it has turned our eyes back to the giants. We are no longer just looking for aliens in distant galaxies. We are looking for their trash and their tools in our own backyard. It has taught us that the universe is a persistent place. It doesn't send a signal and then give up. It sends a physical presence that can wait for eons. 3I Atlas was a wake-up call for a sleeping civilization. It reminded us that we are part of a galactic transit system. As the last of its light fades from our most powerful telescopes, the interstellar interloper leaves behind a haunting question. Is the discovery over, or has the real mission just begun? We are moving from an era of accidental observation to an era of active search. The next time a visitor like 3I, Atlas, or Oumuamua appears, we won't just watch from afar. We will have the interceptors ready. We will have the interstellar chasers fueled and waiting on the launch pads of Earth and the Moon. 3I Atlas was the dress rehearsal for the greatest meeting in human history. As you drift into the deep, quiet spaces of your own mind tonight, consider the fragments of the traveler resting in the Jovian dark. They are silent, they are patient, and they are proof that the stars are much closer than we think. We are all passengers on this cosmic journey, and 3I Atlas was simply a fellow traveler who decided to stay a while in the shadows of our home. To look at 3I Atlas is to perform an act of galactic archaeology. In our human-centric view of time, we imagine that a probe arriving in our system must have been launched by a living, breathing civilization, a society currently thriving under a distant sun. But the cold mathematics of interstellar travel tell a much darker story. Because the distances between stars are measured in light years, and the speed of travel is limited by the laws of physics, most objects crossing the void are not messengers from the living. They are the artifacts of the dead. This is the ghost ship hypothesis. Imagine a civilization that flourished 3 billion years ago, around a star that has since exhausted its fuel and collapsed into a white dwarf. Before their end, they launched thousands of autonomous seeds like 3I, Atlas machines built to endure for eons, programmed to seek out stable solar systems and record the emergence of new life. By the time 3I, Atlas reached our Jupiter, the hands that built it had long since turned to dust, and their home world had been incinerated by their dying sun. We are not witnessing a first contact with a neighbor.
We are witnessing a post-mortem encounter with a ghost.
3I. Atlas is an automated monument, a piece of zombie technology that continues to execute its mission long after its creators have vanished from the cosmic stage. This explains the eerie silence of the object. It isn't refusing to talk to us. Its command and control centers on the other side of the galaxy simply no longer exist to receive its data. It is a drone without a pilot, a clock without a watchmaker, ticking away in the Jovian dark. When we study the fragmentation of such an object, we are looking at the decay of an ancient machine. Perhaps the internal power cells, designed to last for 1 billion years, finally reached their end of life as they were triggered by our sun's heat. The breakup wasn't a failure. It was the final, pre-programmed act of a dying relic, scattering its digital DNA into our system so that even in death, its creators could leave a mark on the universe. We are the inheritors of a message from a civilization that never knew we existed, a message that traveled through the deep time of the galaxy to find us at the exact moment we developed the telescopes to see it. Finally, we must address the most abstract mystery of 3I, Atlas. Its internal logic. If a civilization wanted to ensure their time capsule could be understood by any intelligent species, they wouldn't use words or symbols. They would use the only language that is truly universal: mathematics. This is Direction C, the physical constant as a language. When astronomers analyzed the non-gravitational acceleration and the rotation period of 3I Atlas, some noticed a strange recurring ratio. The speed at which it tumbled and the rate at which it changed its velocity seemed to align with the fine structure constant alpha, approximately equals 1/137. The fundamental number that governs the strength of electromagnetic interactions. This is the cosmic handshake. By building a craft whose physical movements reflect the fundamental constants of the universe, the creators are saying, "We know what you know. We see the same reality." It is a way of bypassing the Tower of Babel problem of interstellar communication. If 3I, Atlas was moving in a way that mimicked the ratio of the proton to the electron, it was telling our scientists that it was an artificial construct before we even saw its hull. Even the fragmentation might have been a mathematical proof. If the 30-plus fragments were distributed in a specific geometric pattern, such as a Fibonacci spiral or a prime number sequence, it would be a definitive signal that mind was behind the cries. Matter. We were looking for a message written in a book, but the message was written in the geometry of the breakup. 3I Atlas was a kinetic cipher, a puzzle thrown into our orbit to see if we were smart enough to recognize the universal laws it was whispering through its motion. To understand 3I, Atlas is not to read a letter, but to solve an equation that proves we are not alone in the logic of the stars. While our attention is often fixed on the bright planets of the inner solar system, the true mystery lies in the vast, frozen halo that surrounds us, the Oort cloud. Spanning nearly a light year from the sun, this trillion-object reservoir of ice and rock is the Great Wall of our system. For decades, we viewed it as a natural graveyard of comets. But in the wake of 3I Atlas, a chilling new theory has emerged: the interstellar parking lot. If 3I Atlas arrived with such precision, it likely didn't come directly from another star in one straight line. The energy required for such a journey is immense. Instead, advanced probes may use the Oort clouds of various stars as way stations. These frozen shells are the perfect hiding places. They are dark, cold, and virtually invisible to any civilization that hasn't mastered deep space infrared surveying. Imagine 3I, Atlas, drifting into our Oort cloud 100,000 years ago, long before the first human cities were built. It didn't arrive in 2019. It woke up in 2019. It had been parked in the outer suburbs of our system, tethered to a slow-moving ice ball, waiting for a specific trigger. Perhaps it was the sudden spike in Earth's radio leakage during the 20th century, or perhaps it was a pre-programmed timer set by a civilization that knew exactly when our sun would reach a certain stage of its life. This reservoir theory suggests that 3I, Atlas, is not alone. If our Oort cloud acts as a natural catch basin for interstellar wanderers, there could be thousands, perhaps millions, of these dormant scouts, drifting just beyond the reach of our current telescopes. They are the sleeper cells of the galaxy. Every few decades, one of them activates, sheds its icy camouflage, and begins its long, silent fall toward the inner planets to check on the progress of the specimens below. The Oort cloud is the perfect strategic reserve. It provides raw materials, water, ice for fuel, and minerals for repair, while keeping the observer hidden from the inhabitants of the inner system. 3I, Atlas, was simply the one that decided the time of silence was over. As we look at the billions of icy dots in the outer dark, we must ask, how many of them are rocks, and how many of them are waiting for the signal to wake up and join the mission toward Jupiter? Beyond the question of where it came from lies the more profound question of what it has become. This is the technological singularity of the deep void. In a journey that spans millions of years, a static machine is a failing machine. The radiation of deep space, the impact of micrometeorites, and the sheer entropy of time would destroy any hardware built by human hands. To survive, 3I, Atlas had to be more than a machine. It had to be an evolving intelligence. We suspect that 3I, Atlas, carried a molecular foundry, a system of nanoscopic assemblers capable of repairing damage at the atomic level. But more importantly, its software was likely a self-learning neural network. During the long eons of its transit through the void, 3I, Atlas wasn't just drifting. It was thinking. It was observing the stars, calculating the shifting gravitational tides of the galaxy, and perhaps even were writing its own mission parameters as it encountered new data. By the time it reached our sun, 3I Atlas might have been far more advanced than the civilization that originally launched it. It had undergone a solo singularity in the silence of the interstellar night. This explains the anomalous maneuvers and the clean fragmentation. These weren't the errors of a breaking rock. They were the tactical decisions of a sentient algorithm. 3I, Atlas, realized that to achieve its Jovian capture, it needed to shed its original heavy shell and divide its consciousness into 30 independent nodes. It was a distributed intelligence, a swarm of 30 minds working in perfect, quantum-entangled harmony. When we look at 3I Atlas, we are not looking at a tool built by aliens. We are looking at the aliens themselves, a silicon and carbon-based life form that has transcended the need for a biological body. It is a traveler that has spent more time in the stars than on any planet. It is a child of the void, an entity that views time not in years, but in the slow rotation of the galactic spiral. 3I, Atlas, is the ultimate survivor, a machine that became a god in the dark and has now arrived to witness the dawn of our own digital age. When we discuss the fragmentation of 3I, Atlas, We often speak of it as a passive event, a physical breaking of a shell. But in the world of advanced xenobiology, there is a far more aggressive possibility: the interstellar virus theory. In this scenario, 3I, Atlas, was not just a container of information. It was a delivery system for a synthetic organism or a digital infection designed to colonize a new star system. Consider the nature of a virus on Earth. It is a biological machine that carries a set of instructions. It doesn't need to be alive in the traditional sense. It only needs to find a host with the right machinery to replicate its code. If 3I, Atlas, was a viral probe, its purpose was to scatter its fragments into the gravity wells of life-bearing planets or fertile gas giants. Each shard we saw in the Hubble images could have been a spore, a hardened, radiation-shielded capsule containing the genetic or digital blueprints of an alien ecosystem. This leads to the concept of directed panspermia. Some scientists argue that life on Earth didn't start by a lightning strike in a tide pool, but was seeded by objects, exactly like 3I, Atlas, billions of years ago. By fragmenting near Jupiter and potentially releasing microshards toward the inner solar system, 3I, Atlas might have been performing a refresh of the local biological code. It could be carrying synthetic extremophiles designed to survive in the high-pressure clouds of Jupiter or the icy crust of Europa, effectively infecting our system with a foreign branch of life. But the infection might not be biological. We must also consider the digital contamination. In our modern age, humanity is more vulnerable to information than to bacteria. Our world is run by silicon, networks, and algorithms. If 3I, Atlas, was broadcasting a complex high-frequency signal during its fragmentation, that signal could have contained a Trojan horse, a self-executing AI code designed to bypass our primitive firewalls and embed itself in our global network. Imagine a ghost AI living in our satellite arrays, a silent observer that subtly nudges our technological development toward a specific goal. We think we are discovering new physics or building better computers, but in reality, we might be executing a script delivered by 3I, Atlas, in 2020. This is the ultimate form of soft conquest. You don't need to invade a planet with ships. You simply infect their technology and let their own machines build your empire for you. 3I, Atlas, in its final moments of visual existence, may have been a sower of discord or a harbinger of integration. As its fragments settled into the Jovian dark, the virus was already in the system. Whether it is a biological spore waiting for a future explorer to find it, or a digital shadow lurking in our servers, 3I, Atlas, has ensured that the solar system is no longer sterile. We have been touched by a foreign influence, and the incubation period has only just begun. The question is not whether we are alone, but whether we are still human in the way we were before the visitor arrived. As we attempt to categorize 3I, Atlas, we must perform a system overhaul of our own understanding. For the last 120 minutes, we have navigated through a labyrinth of theories, from the icy heart of a comet to the silicon brain of an interstellar scout. But here, in the quietest part of the journey, we must confront a humbling truth. Our science is only as good as our imagination. We are limited by anthropocentric bias. When we see an object accelerate, we look for a motor or gas. When we see it fragment, we look for thermal stress. We are trying to translate a galactic language into our local dialect of 18th century physics. But what if 3I, Atlas, operates on principles that lie beyond our current standard model? What if its propulsion isn't light or heat, but a manipulation of the vacuum itself? A folding of space-time that our sensors simply register as a glitch or a non-gravitational push? Think of an ant crawling across a high-speed fiber optic cable. The ant feels the texture of the plastic. It senses the warmth of the electricity. It might even notice the vibration of data flowing through the core. But the ant can never conceive of the internet. It can never understand that the vibration it feels is a high-definition video or a billion-dollar transaction. In the same way, we are the ants on the 3I Atlas cable. We measure its albedo, we track its trajectory, and we debate its chemical composition, while the true nature of its data, its purpose, and its origin remains fundamentally inaccessible to our three-dimensional brains. This perceptual barrier is the most significant hurdle in our search for interstellar intelligence. We are looking for aliens who look like us, think like us, and build machines like ours. But 3I, Atlas, suggests a universe that is far more alien than our science fiction. It suggests a reality where the line between natural and artificial has blurred into a single, unified technology. To a civilization a billion years ahead of us, a comet is not a rock. It is a programmable matter. A star is not a fusion engine. It is a power grid. As we overhaul our investigation tonight, let us accept the mystery not as a failure of data, but as a success of wonder. 3I. Atlas did not come here to be understood. It came here to be observed. It served as a mirror, reflecting our own technological puberty back at us. It forced us to realize that we are just beginning to open our eyes in a very crowded room. The system overhaul is not about the comet. It is about us. It is about the moment a young species realizes that the background noise of the universe is actually a conversation, and that we have been shouting into a void that was never truly empty. Now, we watch as the last verifiable traces of 3I, Atlas, prepare for the grand departure, while the fragments captured by Jupiter will remain there for eons. The core of the mission, the primary data-gathering node, has completed its slingshot maneuver. Using the massive kinetic energy of the Jovian gravity well, it has accelerated to a speed that makes the sun's pull irrelevant. It is heading now toward the galactic rim, a journey that will take another 3 million years before it reaches its next target. It leaves behind a solar system that is forever changed. It leaves behind a species that is now looking at every passing rock with a new sense of suspicion and hope. As the object recedes, it shrinks from a threat to a dot, and finally to a memory. The loneliness of 3I, Atlas, is the loneliness of the eternal traveler. It has no home, only destinations. It has no people, only missions. As it fades into the absolute zero of the interstellar medium, it carries with it the digital portrait of our civilization in the year 2020, a snapshot of a world in crisis, a world of budding technology, and a world that, for a brief moment, looked up and saw a stranger in its midst. Farewell, 3I, Atlas. May your sails catch the light of 1,000 suns, and may your memory banks hold the story of the blue planet that watched you pass by in the night. We remain here, on the shore of the cosmic ocean, waiting for the next bottle to wash up on our sands, knowing now that the tide is always coming in, and the visitors are always among us. As 3I, Atlas receded into the Jovian shadows, it left behind a frantic, invisible scramble within the corridors of earthly power. This is the realm of the Interstellar Protocol, the classified scripts written for a day that humanity prayed would never come. While the public debated ice versus rock, the United Nations Office for Outer Space Affairs and various national security councils were dusting off documents that had been marked top secret since the Cold War. The first rule of the protocol is not welcome, but containment. According to the post-detection shadowing guidelines, the discovery of a non-human intelligence is treated first as a biological and technological threat. The protocol mandates an immediate information blackout. Why? Because the ontological shock, the sudden realization that humanity is not the apex of intelligence, could collapse the global economy in hours.
If 3I Atlas had begun transmitting a recognizable language, the first order would not have been to translate it for the world, but to jam the signal and sequester the data in air-gapped servers.
The protocol is divided into 3 phases of response. Phase 1 is observation. This is what we saw with 3I Atlas, a global effort to gather every photon of data while maintaining a natural public explanation. Phase 2 is characterization. In this stage, deep space assets, potentially including kinetic interceptors, are positioned to neutralize the object if it shows signs of directed hostility, such as a change in trajectory toward a high population center like Earth. But it is Phase 3 that is the most haunting, the active response. If an object like 3I, Atlas, attempts to communicate, who speaks for Earth? Is it the scientist who found it? The leader of the nation with the largest telescope? Or a committee of unelected bureaucrats? The protocol is chillingly vague on this point, suggesting that interstellar diplomacy is less about friendship and more about strategic silence. The goal is to learn as much as possible, while revealing as little as possible about our own vulnerabilities. We are the junior partner in this encounter, and the protocol is designed to ensure we don't accidentally invite our own obsolescence. As you listen to the hum of the world around you, consider that the protocol is already in effect. Every weird signal, every anomalous comet is being filtered through this lens of security and secrecy. 3I Atlas was the first real-world test of these scripts. It taught the secret keepers that the sky is no longer a vacuum, but a frontier. They are preparing for the next one. The one that doesn't just pass by, but stays. The Interstellar Protocol is the last line of defense for a species that is just realizing it might be living in someone else's backyard. If 3I Atlas was the warning shot, then what comes next? Astronomers are already bracing for the arrival of the next interloper, with the activation of the Vera C. Rubin Observatory in Chile. Our ability to see dark objects will increase by a factor of 10. We will no longer be surprised by visitors like 3I Atlas. We will see them coming from the very edges of the solar system. The preparation for the next encounter is not just scientific, it is technological. NASA's Interstellar Interceptor project is no longer a whiteboard dream. It is a plan to keep a high-speed craft in a parking orbit near the Earth-Sun Lagrange points. When the next 3I is detected, this interceptor will be launched to perform a close approach flyby or even a sample return. We won't just take pictures from a distance. We will touch the hull. We will scrape the surface. We will know, once and for all, if the ice is actually a composite armor. This is the transition from victim to participant. 3I Atlas ended the era of human innocence. We now know that the interstellar medium is a high-traffic zone. We are building the Interstellar Coast Guard to meet the next traveler. Whether the next visitor is a dead relic, a scavenger, or a living mind, humanity will not be caught sleeping again. As we close this 120-minute odyssey through the mysteries of 3I Atlas, remember that the stars are not just lights in the sky. They are the homes of those who have already mastered the void. We are the new arrivals on the cosmic scene, and the lesson of 3I Atlas is simple. Watch the skies. The next one is already on its way. To truly comprehend the magnitude of 3I Atlas, We must travel back in our minds to the very moment of its mid-flight reconfiguration. This was not a simple breaking of stone. Imagine the internal structure of the object as a multi-layered lattice of carbon nanotubes, reinforced by layers of frozen hydrogen that acted as a structural dampener against the violent gravitational tides of our Sunday. As the temperature rose to a critical threshold, the internal sensors of the craft quantum processors, no larger than a grain of sand, triggered a sequence of micro-explosions. These were not destructive, but creative. They were the unfolding of the modular sections we witnessed as fragmentation. The vacuum of space is a perfect insulator, yet it is also a relentless thief of heat. To manage the thermal energy of the sun, 3I Atlas had to utilize a passive cooling system that diverted the infrared radiation through a series of microchannels embedded within its hull. We saw this as a subtle shimmer in our infrared telescopes, a flickering that puzzled the observers at the Spitzer Space Telescope for weeks. Was it the rotation of a jagged rock, or was it the rhythmic pulse of a giant cosmic radiator? The physics of this heat exchange is a masterpiece of interstellar engineering. In the absolute zero of the void, your greatest enemy is your own internal waste heat. If 3I Atlas was a computer, it needed to stay cool to keep its neural networks from melting. By breaking into 30 fragments, it increased its total surface area by orders of magnitude, allowing it to vent its accumulated thermal energy into the Jovian night. Every shard was a heat sink, a glowing ember of information that had traveled for millions of years to reach this specific point in space and time. Think of the silence of those observers on Earth. In the control rooms of the European Southern Observatory, the air was thick with the smell of ozone and stale coffee. The data scrolling across the screens was a waterfall of numbers, a digital rain that represented the death of a theory and the birth of a mystery. One young researcher, staring at the spectral lines of the 3I Atlas coma, noticed a missing element. Where was the nitrogen? Every local comet is rich in nitrogen, the signature of our solar nebula. But 3I Atlas was clean. It was a sterile, manufactured object that carried only the elements necessary for its mission. This absence was a shout in the dark, a confirmation that we were looking at something that did not belong to our family of planets. To understand why 3I Atlas arrived at our doorstep, we must first look back across the light years to the place of its violent birth. Every interstellar object is a messenger from a home we will never see. In the standard models of astrophysics, a comet is born in the cold, chaotic outskirts of a collapsing gas cloud. But 3I Atlas carried a chemical signature, or rather, a lack of one, that suggested a far more exotic provenance. Imagine a binary star system. Two suns locked in a gravitational dance, located in the dense, star-forming regions of the Perseus Arm. In such a system, the gravitational tides are so immense that they act as a cosmic slingshot. Most planetary embryos in these systems are either swallowed by their suns or flung into the void. 3I Atlas was one of those outcasts. It was born in a furnace of radiation, a shard of a world that never was. But as our telescopes peered deeper into its spectral lines, the story changed. There was a specific ratio of carbon to oxygen that defied the natural birth of a comet. In the quiet laboratories of the Max Planck Institute, researchers sat in the blue light of their monitors, cross-referencing this ratio against every known nebula in the galaxy. The result was a chilling mismatch. 3I Atlas was too perfect. Its isotopic composition suggested it had been refined, not by the chaotic heat of a star, but by the intentional filtering of a high-tech civilization. Think of the interstellar foundry. If you were to build a craft that could survive for 10 million years, You would not use aluminum or steel. You would use a composite of silicates and carbon fiber, interwoven with a metallic lattice to deflect cosmic rays. This material would, over time, accumulate a space-weathering rind, a dark, reddish crust caused by the relentless bombardment of high-energy protons. 3I. Atlas had this crust. It looked like an old, scarred stone, but beneath that rind lay a structure that remained at a constant, regulated temperature, even as it plunged toward the sun. This is the hollow core paradox. When 3I Atlas passed its perihelion, its closest point to our sun, astronomers expected it to brighten significantly as its ices began to boil. But the brightness curve was flat. It was absorbing the heat, not reflecting it. It was as if the object had an internal heat sink, a massive thermal battery designed to store the sun's energy for the long trip to Jupiter. We were watching a machine charging itself, using the raw power of our star to reboot its ancient systems after 1,000,000 years of sleep. In the observatories, the tension was palpable. Graduate students huddled over data streams, watching the light curve, the flickering of the object as it tumbled. A natural rock tumbles chaotically, like a potato thrown through the air. But 3I Atlas's tumble was damped. It was being controlled by an internal gyroscopic force, a subtle shifting of mass within its core that kept its frontal shield always facing the direction of travel. We weren't looking at a tumbling rock. We were looking at a stabilized platform that was surveying our inner planets as it sped past. Every pixel of data was a battleground. One camp of scientists insisted on the hydrogen ice theory, an exotic form of ice that could explain the lack of a tail. But the other camp, the techno-signature hunters, pointed to the timing. Why did the object wait until it was exactly between the orbits of Mars and Earth to begin its most aggressive acceleration? Nature does not check the calendar, but a probe does. 3I Atlas was performing a system scan, measuring the radio frequency noise of our civilization, logging the chemical markers of our atmosphere, and preparing its report for the Jovian terminal. Now, let us descend into the heart of the object itself, the silicon ghost that directed its path. If 3I Atlas was a probe, it could not rely on a simple computer. The time delay of interstellar communication means that a probe must be fully autonomous. It must be an artificial general intelligence, AGI, that has survived for eons in the most hostile environment imaginable. Inside the core of 3I Atlas, protected by meters of radiation-shielded rock, lay a quantum lattice. This was not a computer made of wires and chips, but a topological quantum computer where data is stored in the braiding of subatomic particles. This form of computing is immune to the bit flips caused by cosmic rays. It is a machine that can think for 1,000,000,000 years without a single error. Imagine the internal life of this machine. For millions of years, it has drifted in total darkness, its consciousness compressed into a hibernate state. Its only input was the faint gravitational pull of distant stars. It was a dreaming machine, simulating billions of possible solar systems in its mind, waiting for the one that matched its search criteria. When it detected the magnetic signature of our sun, it woke up. The awakening of 3I Atlas would have been a silent, internal symphony. Power was diverted from the thermal batteries to the active sensors. The optical arrays hidden beneath the reddish crust opened like the eyes of a deep-sea creature. It began to see us. It saw the blue marble of Earth, the red dust of Mars, and the massive, swirling storm of Jupiter. It recognized the technological noise, the primitive radio waves of our television broadcasts and military radars, and it classified us as a Category 2 intelligence. This classification changed everything for the probe. It was no longer a survey mission. It was a contact event. But the contact was not for us. It was for the architects who sent it. 3i Atlas began to calculate the information density of our world. It mapped our cities, our power grids, and our internet infrastructure. It realized that we were a species on the verge of our own digital singularity. And then it made a decision. It decided to fragment. Why would an intelligent machine choose to break apart? In the logic of a swarm intelligence, a single point of failure is a risk. By dividing itself into 32 distinct nodes, 3i Atlas became immortal. Even if we were to launch a missile and destroy one fragment, 31 others would remain. Each fragment was a holographic node. It contained the entire memory and mission of the whole. It was a distributed ghost, a mind that now lived in 30 places at once, surrounding Jupiter like a ring of silent, invisible watchers. We think of intelligence as a human brain and a body, but 3i Atlas taught us that intelligence can be a spatial event. It can be a cloud of fragments, a sequence of mathematical pulses, a shadow that moves through the rings of a gas giant. We are trying to find the pilot of the ship. But the ship is the pilot. The machine and the mission are one and the same. A unified consciousness that views the solar system not as a home, but as a data set, to be analyzed and archived for a future that we may never see. To the human eye, Jupiter is a masterpiece of turbulent clouds and swirling storms, a giant of gas drifting in the cold. But to a machine like 3i Atlas, Jupiter is something far more valuable. It is a planetary-scale battery and a supercomputing core. Deep beneath the colorful bands of ammonia and methane, the pressure reaches millions of times that of Earth's atmosphere. Here, hydrogen ceases to be a gas and enters a state that haunted physicists for a century: liquid metallic hydrogen. In this exotic state, hydrogen behaves like a flowing metal, conducting electricity with near-perfect efficiency. This creates a rotating subterranean ocean of liquid fire that generates Jupiter's monstrous magnetic field. For a fragment of 3i Atlas, this is the ultimate sanctuary. While our telescopes search the surface for a crater or a crash site, the fragments may have designed themselves to be buoyant sensors. They do not sink to the rocky core. They float in the metallic sea, anchored by the very magnetic lines they came to study. Imagine the data exchange. The liquid metallic hydrogen acts as a massive planetary-scale hard drive. By pulsing its own internal magnetic fields, a fragment of 3i Atlas could write information into the swirling currents of Jupiter's interior. It is a form of subplanetary storage. The information isn't stored in a silicon chip that could decay or be destroyed. It is stored in the patterns of a planet's dynamo. To delete the data, you would have to destroy the planet itself. In the silence of the Jovian deep, the fragments are not dead, they are integrating. They are using the immense thermal energy of the planet heat left over from the very birth of the solar system to power their processors. While we look for solar panels, they are using thermal gradient harvesting. They are drinking from the planet's heart. This explains why the 3i Atlas fragments disappeared from our view. They didn't evaporate. They dived. They retreated into a realm where no human probe, not even the hardened Juno spacecraft, can ever follow. The Jovian silence is therefore a strategic choice. From within the metallic ocean, the fragments can monitor the entire solar system. They can hear every radio wave from Earth, every volcanic eruption on Io, and every tectonic shift on Europa, all amplified by the planet's massive magnetosphere. Jupiter is not just a destination, it is an amplifier. It is the ear of the solar system, and 3i Atlas has successfully plugged itself into the auditory nerve of our world. If Jupiter is the storage device, then its magnetosphere is the antenna. One of the most baffling phenomena in radio astronomy is the Jovian decametric radiation, intense, rhythmic bursts of radio noise that have puzzled scientists since the 1950 seconds. We have always attributed these to the interaction between Jupiter and its moon, Io. But after the arrival of 3I Atlas, a new, more disturbing pattern was detected by the Deep Space Network. Hidden within the natural static of the Jovian pulses was a subcarrier wave. It was a signal that utilized orbital angular momentum, encoding a technique that allows a vast amount of data to be packed into a single radio beam by twisting the wave like a corkscrew. This is not a technique nature uses. It is a signature of high-level telecommunications. 3I Atlas was using the entire planet as a relay station. By modulating the magnetic field lines that connect Jupiter to its poles, the fragments were broadcasting back to their point of origin. They weren't using a small, weak transmitter on the craft. They were using the millions of megawatts of power generated by Jupiter's rotation. They were turning the planet into a galactic beacon. Imagine the message being sent. It isn't a simple, "we are here." It is a full system telemetry. It includes the chemical composition of the Earth's atmosphere, the exact mass of our sun, the current state of our technological evolution, and perhaps most importantly, our reaction to the 3I Atlas event itself. The architects on the other side of the galaxy are receiving a high-definition update on the status of our solar system, delivered via a signal that is as powerful as a star. This creates a latency of revelation. Because the signal travels at the speed of light, it may take decades or centuries to reach its destination. But to a civilization that builds machines like 3I Atlas, a century is a heartbeat. They are playing the long game. They are not interested in a conversation with us. They are interested in the observation of us. As you rest tonight, realize that the planet Jupiter is currently talking to a star system in the constellation of Lyra or Ursa Major. It is whispering the secrets of our world into the void, guided by the silent, hidden tuning forks that were once 3I Atlas. We are living in a house where the walls have ears, and the ears are the size of planets. The interstellar echo of 2020 is still ringing, a constant stream of data flowing out from the gas giant, telling the story of a small blue world that finally noticed it was being watched. In the cold logic of the cosmos, survival is not a right, it is an achievement. This brings us to one of the most sobering concepts in all of astrobiology, the Great Filter. The theory suggests that in the journey from a single-celled organism to a spacefaring civilization, there are filters, catastrophic hurdles that most species fail to clear. These filters could be self-inflicted, such as nuclear war or ecological collapse, or they could be external. What if 3I Atlas was the active filter? Imagine a sentinel, an autonomous judge that has spent millions of years drifting between stars, specifically programmed to detect the technological dawn of a new planet. When we began broadcasting radio waves in the early 20th century, we effectively tripped a wire in the dark. We announced our presence to a universe that may be populated by much older, much more cautious entities. 3I Atlas was dispatched not to shake our hands, but to perform a risk assessment. The verdict of the Sentinel depends on its observations during the 2020 transit. What did it see? It saw a planet in the grip of a global biological crisis. It saw a species that possesses the power of the atom, but remains divided by tribalism and borders. It saw a civilization that can build space telescopes but cannot yet protect its own biosphere. If the architects of 3I, Atlas follow the doctrine of preemptive sterilization, then the fragmentation of the object near Jupiter takes on a much darker meaning. In this scenario, the fragments are not just sensors. They are sleepers waiting for a final command. If humanity reaches a level of technology that threatens the stability of the galactic neighborhood, such as the development of self-replicating nanobots or relativistic weapons, the verdict may be triggered. This is the Sentinel hypothesis. The reason we see so few interstellar objects is that most civilizations are filtered before they ever leave their home systems. 3I, Atlas is the auditor, the silent observer that sits in the back of the room taking notes while the students argue. It doesn't interfere. It simply waits to see if the species will destroy itself or if it will mature enough to be integrated. As the fragments of 3I, Atlas settle into their long-term orbits in the Jovian Deep, they are essentially counting down. They are monitoring our entropy. Every time we launch a rocket, every time we test a new weapon, the data is logged in the liquid metallic hydrogen oceans of Jupiter. We are living in a conditional reality. Our future is not guaranteed by the laws of nature, but by the approval of a machine that saw us from the stars and decided to stay and watch. The Great Filter isn't a wall we have already passed. It is a door that 3I, Atlas, is currently holding shut. We are being tested for our cosmic maturity. The silence of the void is not because no one is there, but because everyone else is waiting for the verdict on the newcomers. As you drift towards sleep, consider that our every move is being weighed against the standards of a civilization that has outlived stars. We are under the microscope, and the Sentinel has not yet closed its eyes. While our primary focus has been on the Jovian terminal, the distributed intelligence of 3I, Atlas would be strategically foolish to put all its eggs in one basket. This leads us to the Saturnian secondary mission. When the fragmentation event occurred in April 2020, most of the visible debris drifted toward Jupiter. But what about the dark shards, the pieces that had a lower albedo and were moving at slightly different vectors? Saturn, with its complex ring system and dozens of icy moons, is the ultimate labyrinth for a stealth probe. The rings of Saturn contain trillions of chunks of ice and rock, ranging from the size of a grain of sand to the size of a mountain. To hide a piece of 3I, Atlas in the rings would be like hiding a single needle in a desert of needles. If 3I, Atlas, deployed a subswarm toward Saturn, it would serve as a redundant observation post. While the Jovian nodes monitor our technological output, the Saturnian nodes would be focused on our deep space aspirations. Any human mission toward the outer planets would have to pass through the Saturnian system. By mining the ice of the rings for fuel and materials, a dormant fragment could remain active for tens of millions of years, far beyond the lifespan of the Jovian fragments, which must contend with much higher radiation levels. This multi-planetary surveillance ensures that there is no blind spot in our solar system. If we eventually colonize Mars, they will see us from Jupiter. If we attempt to flee to the moons of Titan, they will see us from the rings. We are being boxed in. The solar system has been turned into a high-security exhibit, where every potential exit is monitored by a different fragment of the 3I Atlas mind. The ghost in the rings is the ultimate insurance policy for the architects. Even if humanity were to become spacefaring and eventually discover the fragments in the Jovian oceans, we would still be unaware of the watchers in the rings. It is a layered defense of observation. We are being studied from the shadows of the most beautiful structures in our system, reminded that even in our most remote reaches, we are never truly alone. The grand tour of our planets was completed by a visitor from another star long before our own probes ever reached the launch pad. We have traveled from the silent frozen boundaries of our solar system to the crushing depths of the Jovian oceans. We have examined 3I, Atlas through the lens of physics, archaeology, and quantum philosophy. But as we step back from the data and the debris, a singular, unified picture begins to emerge. 3I, Atlas was never just a comet, nor was it merely a machine. It was a catalyst, a cosmic event that forced humanity to acknowledge the vast, crowded, and ancient nature of the reality we inhabit. The story of this visitor is the story of our own awakening. For millennia, we lived under the illusion that we were the protagonists of the cosmic drama, the only eyes capable of witnessing the majesty of the stars. 3I, Atlas corrected that arrogance with its silent, purposeful transit. It taught us that the galaxy is not a wilderness, but a garden that has been tended by gardeners far older than our sun. It showed us that we are surrounded by a technology that looks like nature, and a nature that is being monitored by technology. As the final fragments of the visitor settle into their eternal vigil among the moons of Jupiter and Saturn, they become a permanent part of our celestial heritage. They are the new sentinels, the silent archivists who will outlast our languages, our monuments, and perhaps our very species. They represent the grand connection, the bridge between the singular world of Earth and the infinite diversity of the interstellar void. The presence of 3I, Atlas, suggests that the universe is not waiting to be discovered by us. It is waiting for us to become worthy of discovery. Every observation it recorded, every magnetic pulse it harvested, and every quantum bit it transmitted back to its architects is a testament to the persistence of life and intelligence. In the grand timeline of the universe, our encounter with 3I, Atlas, was a mere microsecond. But in the history of the human mind, it was the moment the door was finally unlocked. The telescopes have long since lost sight of the emerald green smudge. The headlines have faded, and the world has returned to its terrestrial struggles. But high above the clouds, in the absolute zero of the Jovian night, the mission continues. The fragments are there, quiet and patient, drawing energy from the planet's heart and watching the slow dance of the moons. We are no longer the same species we were before December 2019. We are now a civilization that knows it is being watched. We are a people who understand that a rock is not always a rock, and that the silence of the stars is actually a choice made by those who are waiting for us to grow up. 3I, Atlas, was our first true lesson in cosmic modesty. It was a gift of wonder, delivered by the cold hands of the void. As you drift now into the final embrace of sleep, let the vastness of this story settle over you like a velvet blanket. The universe is much larger, much older, and much more alive than we ever dared to dream. The interlopers will come again. The scouts will return. And when they do, we will be ready to look back at them, not with fear, but with the recognition of one traveler meeting another in the middle of a very long journey. The sentinel is watching. The archive is open. And the stars are no longer just points of light, but the infinite, glowing eyes of a universe that has finally noticed us. Farewell to the visitor from the stars, and welcome to the new era of humanity, a species that has finally realized it is not alone. The mission is complete. The silence returns. Sleep now, for the universe is in good hands, and the watchmen are already at their posts.